With the proliferation of hack attack on just about every aspect of the network and user devices, there's no device that is exempt from possible attack. One of the many devices that has possible security vulnerabilities is the network router. If an attacker gains access to a router and corrupts the router's routing table, the attacker can redirect the victim's traffic. Within the network, routing is the most important part of the infrastructure, and to prove that, you only need to look at the QoS settings for routing protocols. With an IP precedence of 6 or a DSCP value of 48, all routing updates take priority over all traffic on the network. Or to put it in other terms, without routing, the whole network is down. It's very important that the security analysts have a good basic understanding of how IP routing works and how to identify potential attacks and take protective measures to prevent them. Routers use routing protocols such as RIP, EIGRP, OSPF, and BGP to collect routing information from its neighbors and update its neighbors of any changes to the network as they happen in real time. Routers terminate the Layer 2 collision in broadcast domains. While switches switch data frames between devices on the same LAN, routers are required to reach hosts that are not on the same LAN. Once a router receives all the updates from all its friends on the network, the entries are put into a topology table where the routing protocol algorithm calculates the best path to each network. For example, OSPF uses the Dijkstra algorithm and EIGRP uses the diffusing update algorithm or dual to calculate the best route to each network. Each routing protocol uses its own metrics to determine the best path to a network, such as RIP using hop count or distance, and EIGRP using minimum bandwidth and delay. The administrator can influence or provide traffic shaping by adjusting variables such as bandwidth, or applying route maps to influence which path the packet will take. Once the routing protocol has built a topology table and used its algorithm to find the best path to each network, it creates a routing table. It's this routing table that's used to determine how to forward packets. Router protocols can be grouped in many ways, such as if the protocol is an interior gateway protocol or an exterior gateway protocol. Interior gateway protocols are used within the organization and exchange routes with an autonomous system. Commonly used interior gateway protocols are EIGRP and OSPF, although you'll sometimes find RIP as well. ISIS is commonly found within the service provider internal network. Exterior gateway protocols exchange routes between different autonomous systems. The only exterior gateway protocol in use today is BGP. Another way you can group routing protocols is based on how or what metric they use to determine the best path to a network. Distance vector protocols exchange routes with other routers as vectors or distance, sometimes called hop count. EIGRP and RIP version 2 are distance vector protocols. Link state protocols exchange complete topology maps of the network via link state advertisements. Each router determines the best path from itself to every network using the shortest path first algorithm. OSPF and ISIS are the two main link state protocols used today. Path vector protocols exchange routes as the vector of path and direction. BGP is the only path vector protocol used today. As shown in the sample log, you can see that IP address 192.168.1.2 is sending RIP version 1 request as a broadcast to the network. If you, the security analyst, were to see many of these entries in the log, it's quite possible that this is a DOS attack to make the network resources unavailable. Malicious attackers could also spoof the source IP address and craft similar query types that you see in the log file to try and create a neighbor relationship with the unsuspecting router. If this relationship was to form, the attacker could obtain a complete set of routing information on the network. These entries in the log could also be legitimate router updates. It's up to the security analyst to understand the normal operation of the network and to be able to identify the difference between normal and malicious traffic.